Hello, welcome dear students. This time we start a fresh topic and the name of the topic is mathematical method. So let's see the syllabus of mathematical methods. Section A contains linear integral equations of first and second kind, Abel's problem, a relation between linear differential equation and Volterra's equation, non-linear and singular equation, solution of successive substitutions, Volterra's equation, iterated and reciprocal function, Volterra's solution of Fredholm's equation, Fredholm's equation as limit of finite system of linear equation, Hardmer's theorem, convergence proof, Fredholm's two fundamental relations, Fredholm's solution of integral equation when d lambda is not equal to 0, Fredholm's solution of a direct Dirichlet problem, and Newman's problem, lemmas on iterations of systematic kernel, symmetric kernel, so large inequalities and its applications. Similarly, we have section C, simple variation problem, necessary condition for an extremum, Euler's equation. All the section B is dependent on Euler's equation. So this is the syllabus of mathematical methods. Let's start this video. First of all, for this we required strong integration base of each student. So I start with my video, this video with some integral formulas. I advise all of the students that they should note down all this integrals formula. Whenever we required and whatever we required, we use this formula in the solution of integral equations. So first we have standard integrals. First is x raised to the power n dx is equal to, this we have done in +2 level. So I start from there. X raised to the power n, integral of x raised to the power n is 1 over x raised to the power n plus 1 over n plus 1. Integral of 1 by x dx is equal to log x. E raised to the power ax dx is equal to e raised to the power ax over a plus c. So every time there is a constant of integration when we have indefinite integral, and when we have definite integral there is no need of plus c. That is a unique answer is there. So similarly log x is there. Log x is x into log x minus x, and then sin ax. Sin ax is minus 1 by a into cos ax. Integration of cos ax is 1 by a sin ax. Tan ax is equal to minus 1 by a log cos x, and it may be 1 by a log secant x. So sin ax, this is a hyperbolic function, sin ax is equal to 1 by a cos ax, and cos ax is equal to 1 by a sin ax. Similarly, we have tan, hyperbolic function, tan ax is equal to 1 by a log cos ax, and this is the standard results which we use in +2 level. 1 over a square root of a square minus x square dx is equal to sine inverse x over a, or we can write arc of sine x over a. Similarly, 1 over a x square minus a square under root is equal to arc of cos x over a, or log x plus square root of x square minus a square. 1 over integral of 1 over square root of a square minus x square dx is equal to arc sin x over a, or log of x plus square root of a square plus x square. 1 over x square plus a square is equal to 1 over a tan inverse x over a, or arc tan inverse x over, or arc tan x over a. Similarly, we have this 1 over a square minus b square x square dx is equal to 1 over 2ab log of a plus bx over 1 minus a bx. More standard results are there when we have using algebraic equations. A plus bx raised to the power n, that is a plus bx raised to the power n plus 1 over n plus 1 into coefficient of x. So student, just remember that the coefficient of x is written in the denominator. Similarly, 1 over ax plus b, a plus bx dx is equal to 1 over b, because coefficient of x is b, so log of a plus bx. Similarly, we have these results which we prove in plus 2 class, and now come to the other one. These all we have done in plus 2 level. My advice to all students is just write down these results in your notebook, so that whenever required we can reproduce it. And similarly, all these are related to the irrational function. So here 1 over x square and root a plus bx, when we have, this is pure quadratic and this is a linear, so we put linear equation is equal to t, and we got this answer. And similarly, all these results are there. This result we have used n raised to a plus bx raised to the power n by 2, and then n by 2 plus 1, and similarly a coefficient of x we write in denominator, and we got this. And then come to this irrational function, square root of a square plus x square, that is x by 2 square root of a square plus x square plus a square by 2 into sine inverse x by a. So to prove this result we use into 1 method, dot 1 लगा के भी कर सकते थी, और दूसरा second method we have to put x is equal to a tan theta. Similarly here, and this results we can prove in plus 2 level. So come to the next one, 1 over a square plus x square whole square, and here we use partial fraction, and when we use partial fraction we got this type of result. Come to trigonometrical. Now this is the trigonometrical part of integration. Sin ax is equal to 1 by minus 1 by a cos x, and sin square ax. Sin square can be written as 1 minus cos 2ax by 2, and the integration is 1 means x by 2 minus sin 2ax over 2a, and then multiply with 2 we got 4. Similarly, cos ax, cos square ax, and this here sin ax into sin bx. So students should remember this result, sin ax into sin bx, multiply and divide by 2, then apply CD formulae, and then we got this sin a minus b into x over 2 a minus b minus sin a plus b into x over 2 a plus b. Similarly, cos ax, cos bx, sin ax, cos bx, sin ax into cos ax. Sin ax into cos ax, multiply and divide by 2. So we got 2 sin ax cos ax, that is sin 2ax, and here it's a substitution, it's find by substitution. So this result has 2 answers. Now this is the product of trigonometry and algebraic function, and this is by parts integration. All these results from by parts, but this 59 results, students be very careful. This is exponential and trigonometrical. Exponential and trigonometrical. My advice is write down this 59 and 60 somewhere, which you can see in daily. E raised to the power ax into sin bx is equal to e raised to the power ax over a square plus b square, a sin bx plus minus b cos bx. Similarly, e raised to the power ax cos bx dx is equal to e raised to the power ax a square plus b square, a cos bx plus b sin bx. Secant ax, 1 by a log secant ax plus tan ax, and cosecant ax is equal to 1 by a log cosecant ax minus cot ax, and cot ax is equal to 1 by a log sin ax. So tan square is a secant square minus 1, so by using that inequalities, and then we have identities. Similarly, secant square is equal to 1 by a tan ax, cos square is equal to cosecant square is equal to minus 1 by a cot ax, and cot square ax is equal to minus 1 by a cot ax minus 1. So this is sin inverse ax. So when in plus 2 level we do this, we make a product sin a inverse ax into 1, and then by use I late formula or product of integration formula. Similarly, these 69 and 70. Now come to exponential function only. So these results are exponential and logarithmic results. So e raised to the power ax, b raised to the power bx, and so on. So this is a hyperbolic function, sin ax 1 by a cos ax, sin square ax is equal to sin 2a x over 4a minus x by 2. Similarly, these two results. These are the results from hyperbolic function. So students are advised again to remember these results from lower section. Now come to this part. This part is when we have definite integral 1 to infinity, integration from 1 to infinity 1 by x raised to the power n. So x raised to the power minus n, and then x raised to the power minus n minus 1 plus 1 over this, and then we use definite integral property, that is integration from a to b. First we put b, then we put a minus into f of a, f of b minus f of a. So all these results are from definite integral, and particularly this result when we have secant, cosecant inverse x, students should remember these results. Similarly, here we have another results. I advise again students should write down all these results. One particular result is applied in integral equation so many times, and that is Leibniz rule of differentiation under integral sign. I suppose that students are not familiar with this result, but let f xt and curly f by curly x be the continuous function of both x and t, and let the first derivative of gx and hx be continuous. Then this integral sign derivative along with integral sign is equal to integration from gx to hx, and when we go further, this fx is partially differentiated with curly f by curly x into dt plus f into x hx into derivative of h with respect to x minus f into x gx and derivative of g with respect to x. So this is the Leibniz rule of differentiation under integral sign. Many times we repeat these results in our further study also. So this is again integration of trigonometrical function, and using some properties and property or definite integral, properties of definite integral, which we study in +2 level. So all these integrals we study in +2 level. Here the topic which we want to discuss is integral equation. So in mathematical method, our first topic is integral equation. So integral equation is this type, and an equation which contains integration is known as integral equation. First is fx is equal to a to b kx t y t dx. Second equation is of form fx is equal to yx minus lambda into a to b kx t and yt. And third one is this type, fx is equal to a to b or b to a f kx t yt square. So these two first two are linear integral equation, whereas third one is non-linear integral equation, and this is the multiple integral also because yt square is there. So now come to the next part, that is types of integral equation. The first one is when limits are constant, the second one is when limits are variable, and third one is when limits are infinite. When limits are constant, so constant limits means we have Fredholm's integral equations. Second, when we have limits are variable, so Volterra's integral equation. And then third one is when limits are infinite, we have singular integral equations. So students, in next video we will discuss all these differential integral equations in detail. So let's start the next lecture. Thank you.